In this video, we're going to be talking about eclipses, both solar and lunar. Here we go. Eclipses. An eclipse is when one astronomical object casts a shadow on the other. So this is a shadow event. Eclipses are named for the object that is blocked from view. For instance, a solar eclipse is when a moon casts a shadow on the Earth. Basically, we can't see the sun. That's why it's a solar eclipse. Can't see the sun, solar eclipse. Remember, we name them for things we can't see. A lunar eclipse is when the Earth casts a shadow on the moon, which means we can't see the moon, hence lunar eclipse. Geometry of shadows. The shadow created by an object in space has two parts. So there's an umbra portion of the shadow, which is dark, where all the sunlight is blocked. So if you look at this picture in the upper right-hand corner, the umbra is this inner part of the shadow where all of the sunlight is completely blocked. So the moon would be fully dark there. This produces a total eclipse. So if you look at the bottom right-hand corner, we have a total solar eclipse. Now this one's a little bit annular, which means it's just not covering quite the entire sun, but that's going to be your maximum darkness, is when you are in the umbra. The penumbra is shaded, but sunlight is only partially blocked. So if the moon was out here in this penumbra region, in this lighter gray, some of the sunlight would still hit it. So this produces a partial eclipse because you can still see part of whatever object you're seeing. Part of it is a penumbra, it's a partial eclipse. And you can see that in the picture where only part of the sun is blocked in that solar eclipse, that partial solar eclipse. So the moon phases and eclipses. Now keep in mind, this is not to scale. But if we had a lunar eclipse, right? We got a lunar eclipse, that means we have the sun, the earth, and the moon. The only way to get a lunar eclipse is if the earth is blocking the sunlight from the moon, which means this would have to be a full moon location. If we were gonna have a solar eclipse, we have to have the sun, the earth, and then the moon would have to be in between them. The only way that the sunlight could be blocked is if something got in between us and the sun. And in that case, it would be the moon. So anytime we have these three objects in line, the sun, the earth, the moon, when they're in a line, this is my favorite word, that's called syzygy. Try using that in Hangman, it's a lot of fun. We have to have syzygy in order for an eclipse to occur. If we have syzygy and the moon is full, then we could get a lunar eclipse. If we have syzygy and the moon is new, it's possible to get a solar eclipse where the earth might be, blocked from us. So wait a second. Why don't we get eclipses twice a month then? Why wouldn't we get an eclipse every time there's a new moon? Why wouldn't we get an eclipse every time there's a full moon? Well, the moon's orbit is tilted compared to the Earth's. So due to the tilt of the orbit, the sun, earth, and moon don't always perfectly line up. If you look at this picture over here, we got the moon, right? And it orbits the earth. It revolves around the earth. But it doesn't revolve in a flat line along the same plane as Earth. It's actually tilted at a 5-degree angle. We call that from the ecliptic, or the route that the Earth orbits around the sun. So what happens is sometimes the moon is too high up to cast a shadow on the Earth. Its shadow would be above it. Sometimes it's too far down where it wouldn't pass through the shadow of the Earth. So if things don't line up perfectly, this isn't gonna work. So eclipses are super rare because even though the orbit is only tilted 5 degrees to the Earth and moon are super tiny compared to the distances between them. That last picture doesn't truly show the huge difference that 5-degree tilt can make. If you look at this picture at the bottom, the moon, even though it's just 5 degrees, look at how far away it is. 5 degrees of a huge distance means that if it's all the way up here, there's no way it's going to cast a shadow on the Earth. So the only way for it to truly line up would be the times when it's going through its orbit and it actually passes through that same plane as the orbit of the Earth around the sun. The alignment must be nearly perfect in order for an eclipse to occur. So solar eclipses. The moon must be new in order for a solar eclipse to occur. Now, new doesn't mean that it just formed, right? New just means that it's in the new phase of its cycle, meaning we can't see any of the moon. That dark half of the moon is facing us. The moon is much smaller than Earth. Fun fact. So what that means is it's going to have a small umbra, which means a very small total eclipse area. You can see in this picture, look at that umbra. The only portion that's getting a total eclipse is that part of the Earth that's directly underneath the umbra. So most of the Earth can't see that. It does have a larger penumbra. You can see that the penumbra is much larger than the umbra for the moon, which means many people can see a partial eclipse. So anybody standing in that shadow at this time would see a partial eclipse. Solar eclipses, the distance from the Earth really impacts how much of the sun is blocked. The closer to the Earth, the more people can see the eclipse. If the moon is closer to the Earth, it's going to cast a larger shadow because of how close it is. If it casts a larger shadow, then more people are standing in that shadow and more people can see that eclipse. An annular eclipse is when the moon is actually further away from Earth and it isn't large enough to block out the whole sun from the Earth's perspective. It doesn't change size. It just doesn't look like, it's large enough. So basically what happens is sometimes the moon is closer to us, sometimes it's further away. Maybe you recall the Earth also does that to the sun. Sometimes we're closer, sometimes we're further away. This doesn't greatly impact the energy, but it does impact the size of the shadow that an object casts on another. So in an annular eclipse, the moon is a little bit further out, and this umbra is now super small. And if you look at this picture, if you were standing on Earth, what you're going to see is kind of this ring effect, where yes, it's blocking out the sun, but it's not large enough to block out the whole thing. That's an annular eclipse. So solar eclipses, due to the Earth's rotation and a small shadow of the moon, only limited people can see a total solar eclipse, and they only last for a few minutes at best. This was the Great Eclipse back in 2017 on August 21st. I was there. It was great. I went all the way over here to Wyoming to watch it. And so when this occurs, the greatest duration of this eclipse was 2 minutes and 40 seconds. Now that's not very long. And the reason why this route of the path or of the shadow moves in this manner is because of the way that the moon is moving through space and also the way that Earth is moving through space. Earth is still rotating, so it's not like this shadow is going to be cast on just one singular location. It's going to travel as the Earth rotates. And if the moon is moving through its orbit and the Earth is moving through its orbit, it's also going to cause that shadow to move, which is why the shadows of these eclipses change every time there's an eclipse. For instance, when will you be able to see a total solar eclipse in the United States? Well, your next big shot is April 8th in 2024, which is my brother's birthday, fun fact. The picture in the top right-hand corner, that shows you the path of totality. So the path of totality is in this darkest area. That is the path that the umbra will trace. So if you want to see a total eclipse, you have to travel to one of those locations in that path of totality. Now, if you're interested in doing this, a lot of these locations are actually already selling hotel rooms. They're already selling campground space for this eclipse. So, get on it. Otherwise, you might miss it. If you miss it, don't worry. There'll be another one in 2044, which is insane. So the one in 2044 is on August 23rd. And if you look at this bottom map, it's actually only this part over here where it's going to be in North Dakota and Montana. In the United States, that's the only location where you'll be able to see totality. Even more so, in 2045, that'll be another good one. On August 12th, that'll actually be a much larger area. You can see the path that it traces here. That'll be another good time to see it. But if you don't want to wait, like 25 years, try to see the one in 2024. And even if you don't get to the path of totality, a partial eclipse is equally, well, maybe not equally, but it still looks cool. Solar eclipses can be challenging to experience, but are so worth the effort. If you look at this picture, look at that gorgeous solar eclipse. It looks like it's nighttime. Some people would confuse this for a lunar eclipse, but in fact, as that moon blocks out the sunlight, it looks like sunset in every direction. It is so cool. In this one, you can see this is a time-lapse video. There's not multiple suns, just so you know. It's just this took time. And so you can see how it slowly covered up the sun. We had peak totality with this diamond ring effect. And then it started drifting away. Yeah, and that's it. It's that quick. Here's another solar eclipse that's happening just over the mountains. Gosh, it's so cool. Yeah, solar eclipses can be challenging to experience, but again, they're so worth the effort. Look at those pictures. They look cool. If you feel like watching this on your own time, this is a video that I took when I went to see the solar eclipse in Wyoming. It was so cool. The birds started making weird sounds. The wind changed. You could see planes. I couldn't see any stars. I think all the lights I was seeing were planes. But it was just a really cool experience. Eclipses do occur on other worlds. Fun fact. Other worlds have more moons, which means they have more eclipses. Now, most of the other worlds, their moons are much smaller than ours. So they're going to have a smaller path of totality. But if you look at this picture on the right, Jupiter sometimes has 3 eclipses occurring at once because it's so huge, which, is just pretty cool. On Mars, there's actually eclipses as well, but almost all of them are annular eclipses. And that's because its moon is so small that it can't block out the whole sun from Mars. This one is courtesy of the Curiosity rover that's roving around on Mars. Lunar eclipses are eclipses, right? They're shadow events, but this time we can't see the moon. So in order for this to occur, the moon must be in its full moon phase. It has to be on the far side of the Earth compared to the sun in order for it to pass through our shadow. The Earth is much larger than the moon, which means there's a larger umbra, which means we're going to see more total lunar eclipses and more people will be able to see them because the moon has a higher probability of passing through that shadow. It also has a larger penumbra, which means many people can see a partial eclipse. Basically, if there's going to be a lunar eclipse, not all of the Earth will see a total lunar eclipse. A lot of people will, but not everyone. Literally everybody at night will be able to see a partial lunar eclipse when it happens, which is pretty neat. So the moon passes through the shadow of the Earth. That is a lunar eclipse. Because the shadow is large, lunar eclipses last longer. So instead of lasting minutes and minutes at best, like a solar eclipse, what we're seeing are eclipses that can last for over an hour. And the transition time takes quite a bit. So if you're planning a night to watch a lunar eclipse, take your time, maybe bring a board game, hang out with some peeps. You got some time on your hands in order to see that totality. Everyone on the night side of the Earth will be able to see a lunar eclipse if it's happening, but it just might not be a total lunar eclipse. The blood moon. So total lunar eclipses are also called blood moons. Why does the moon turn red during totality? Which it totally does, by the way. If you see a total lunar eclipse, it's going to start turning kind of orange and then kind of red. And there's a reason for that. Light gets refracted through Earth's atmosphere. What that means, it gets bent. And as it gets refracted and bent, it actually increases the wavelengths of the light that's passing through it, which makes it turn red. Red has a longer wavelength than blue, than green, than orange, than yellow. It actually has the longest wavelength of visible light. So this is also why at sunsets and sunrises that we see a reddish horizon. And that's because as the sun rises in the horizon, it's passing through all of that atmosphere, causing it to stretch out that sunlight, making it red. Now the moon, at this time, it turns red because all of the light through every sunrise and sunset on the Earth is being sent towards the moon, making it a combination of all those sunrises and sunsets in the world. Boom, we get red, which is pretty neat. Yeah. So cool lunar eclipses. Take a look at that one. That one's cool. Oh, look at that one. That's cool time lapse. That looks like it's a cool island. I don't know. So when we get eclipses, what we got is we have the sun, we have the Earth, and we have the moon all lined up. Where the moon is totally depends on its orbit, and the phase will change based on that, and what type of eclipse we get will change based on that. And keep in mind that 5-degree tilt of the moon's plane tells us that we can't get eclipses every single lunar cycle, but we do get them like twice a year. Yeah. All right. Well, that's all I got. Thank you for your time. And if you have any questions, feel free to send me a comment.